Right, 9p. Because we've reached the end of Unit 7, we're due to do our test, which is on both Units 6 and 7. Now they're both pretty big units and there's a lot of stuff going on in them. So we're going to spend the next few lessons just doing a little bit of revision on everything. So Unit 6 was all about circles and then a little bit on volume as well. So the first thing that we need to make sure that we remember is all the different parts of the circle and how we label them. So the first one is the circumference, and the circumference is really just the special name for the perimeter of the circle. It's the distance the whole way around the outside. So if you were to start at one point on the circle and walk your whole way around, you would have walked around the circumference of the circle. The radius is the next one that we need to know. Now the radius is the length between the center of the circle the whole way out to the edge of the circle. And that'll be the same whether it's drawn on here or here or here. Doesn't matter. It's going to be the same distance the whole way round for the radius. Now the diameter is the distance the whole way across the circle. But whenever you're marking the diameter on, it has to be the distance the whole way across through the center. And because of that, the diameter is actually equal to double the radius. Because if we look, the radius is from the center to the edge. So this little bit of this one is the radius. And from here to here is the radius. So both of these lengths here are radius. So two radiuses gives you the diameter. So the diameter is just double the radius. So if you have a radius of 4, your diameter will be 8. If you've got a radius of 20, your diameter will be 40. Now, the first rule that we looked at was how to calculate the circumference of the circle, and we've got two different equations that we can use for that. So the circumference is 2 pi r, that means 2 multiplied by pi multiplied by the radius, or you can use circumference equals pi d. So the circumference is equal to pi multiplied by the diameter of the circle. So we've got a couple of examples using those. Now my advice would be you can use either one of these equations. If the question gives you the radius, then use this top equation here. Use the equation that has the radius in it. If the question gives you the diameter, then use this bottom one. So just pick the equation that best suits the question that you're doing. Now, the first example was find the circumference of a circle with radius 8 centimeters and give your answer to 3 significant figures. So we'll start off using c equals 2 pi r. Because the question has given us radius, then that's why we chose the equation that has the radius in it. There's a whole lot of sunlight coming in here. Hopefully you can still see without too many shadows. Hopefully it's not too bad. Okay, so c is 2 pi r. The radius is 8. So from this line to this next line, all I've done is rewrite my equation, but filled in the numbers that I know. Now, we know really that pi, if we were to round it to 2 decimal places, is 3.14. But instead of doing that, we just use the pi button in our calculator because it's much more precise. It gives us much more detail. So c equals 2 multiplied by pi multiplied by the radius, which was 8, and we type that into our calculator. Now, just to remind you how you get that, if you have a Casio like me, then do you see how above the times 10 to the power of x button? Now in mine it is in yellow writing. There's a wee yellow pi written there. That means that if I hit shift and then that times 10 to the x button, that gives me pi. So shift and then times 10 to the x, and you'll see on my calculator screen it now says pi. So that's how I get that. I get that on my calculator. So I'll try and keep this in the screen so you can see what I'm typing. I don't know if it will all fit. Not quite. So if I'm typing 2 times pi times 8, I hit 2 multiplied by shift and then my times 10 to the x button, and that gives me pi multiplied by 8. Now if you look on my screen to see how that now says 2 times pi times 8, So always be checking that wee line on your calculator as you go to make sure that you are actually typing it in right. And if I hit equals, I get 50.26548.246. Now, the question had asked us to round our answer to 3 significant figures. So we look, and the 1, 2, third significant figure is the 2. So that's why I've drawn a wee line there. The number after that is a 6. Because that's above 5, that tells us that this rounds up. So this rounds to 50.3 to 3 significant figures. Okay, so let's look at example 2. So this time the question had given us the diameter. So find the circumference of a circle, diameter 18 centimeters, and again give your answer to 3 significant figures. So because the question's given us the diameter this time, that's why we chose this equation. So C equals pi d. The diameter is 18, so C equals pi multiplied by 18. And whenever we type that into our calculator, we get this big long number here. Now, because we have to round it to 3 significant figures, I found my third significant figure. The number afterwards is a 4. That tells me to round down, so this stays as 56.5. And because circumference is just a length, our units are just the same units as the diameter. They are centimeters. Okay, let's look at the next page in our notes. Hopefully you're following along with your notes. So the next thing, once we did circumference, was to look at what we would do if we were given part of a circle and asked to calculate different lengths and things like that. So if you end up with a part of a circle like this, we would call this bit here the arc, and the arc is just part, it's a portion of the circumference, so it's part of it. And if, like for example, without looking at all the rest of this, if we had a semicircle like this, then it's fairly obvious to us that the length of this arc is going to be half of the total circumference. Or if we had a quarter of a circle, it's going to be obvious that the length of the arc is going to be a quarter of the full circumference. But we don't always have nice, neat circles like that, so we have to have a general rule. So this is the rule that we use. So we do that whatever angle we have in our circle divided by 360, because that's just the fraction of the circle that we have. If we had 60 degrees, it would be 60 over 360, because it's 60 360ths of the circle, multiplied by the equation for the circumference. And again, use radius. Most of these questions will give you radius, so you'll use the radius equation. Or if the question gives you the diameter, use the diameter version. So let's look back at this first example here. Find the perimeter of a semicircle with diameter 6.5. So because they hadn't given me the circle in the question, I drew it out because it's always easier to picture what's going on if you draw it out. So we've got a semicircle, the diameter was 6.5. So using this rule from up here, the length of the arc is equal to the angle that we have. So this angle here is a straight line, so this angle is 180 degrees. So 180 over 360 multiplied by the full circumference, which in this case, because they've given us the diameter, is pi d. Now, I simplified this from this line to the next. 180 over 360 simplifies down to a half. That's fine. You don't have to, because you're going to end up typing this into your calculator anyway. Multiplied by pi, multiplied by the diameter, and that gets us 10.2. Now be careful. Sometimes questions will just ask for the length of the arc, but sometimes, like in this one, they'll ask for the perimeter. So if they ask for the perimeter, that means the whole length around the whole shape. So in this one, for the perimeter, we have to include this straight side here. So my perimeter is going to be the length of that arc that I've just figured out, which was 10.2, plus the straight side, which was 6.5, and that gets me 16.7 centimeters. Right, example 2 on the same page. So again, this one's asking for perimeter. Now careful, the questions won't always ask for perimeter. Sometimes they'll just ask for the length of the arc. So this time our angle was 60. And the length of the arc, we use our equation from the top of the page there. So whatever angle we have, 60 over 360. because that's the fraction of the circle that we have, multiplied by the equation for the circumference. Now, in this one here, we would have had to decide whether we were using 2 pi r or pi d. But if we look back at this shape, like this point here is the center of the circle, so this 9.5 is the radius. So that's how we knew we were using 2 pi r in this case. So again, I've simplified going from here to here. You don't have to, because you're going to be typing this into your calculator anyway. And you can just leave it like this. So anyway, I simplified here, multiplied by 2, multiplied by pi, multiplied by the radius, which is 9.5, and I've got that from over here. So that got us 9.95 meters. So this is the length of the arc, but for the perimeter, remember that's the whole way around the entire shape. So our shape is this little like pizza shape here. So we've got the arc, plus we have to add in this side. So that one I've coloured in red, my colours aren't showing up very well here, so that's that, plus this green side. And if this is the centre of the circle and this is the edge of the circle, then this is also the radius, so this is 9.5 as well. And then adding that all up gets us 28.9 meters. Okay, next page. Remember, year 9, I'm going to be giving you exercises for all of these different sections, so make sure you're pausing the video at the right part and going and doing the questions. I should have said that at the start and forgot, sorry. But pause the video, do questions on the stuff I've just been talking about. It's just easier to have it all as one video. Right, anyway, the next section is area of a circle. So the equation that we use for the area of a circle is A equals pi r squared. And we never really use the diameter version of this. So if the question gives you the diameter, remember you can just divide that by 2, and that'll get you the radius that you can use in here. Now it's important to note in this equation, it's only the radius that is squared. So make sure you're careful whenever you're typing that into your calculator. So, nice and straightforward example. Find the area of a circle with radius 6 centimeters. So we use our equation A equals pi r squared. I've just rewritten this, substituting in the numbers. Question had told me the radius was 6, so I put that in here. So pi multiplied by the radius, which was 6 squared. And that could give me that. Okay. Example 2. So in example 2, this was one where they had given us the diameter and not the radius. So the first thing we had to do was calculate what the radius was, and that's just the diameter of 18 divided by 2, and that gets us 9. Once we know the radius, we can put that into our equation A equals pi r squared, and hopefully you can follow what's going on there. Then example 3 is relatively straightforward. So we've been given the radius. And all I've done is substituted that into the equation. So you don't really need me to talk you through that, I'm sure. If you do, ask. It's the same as all the ones above. Just be careful. This is something I quite often fall for. I am so used to, in these types of questions, lengths and stuff being given in centimetres, that I quite often miss it if it's like this. See the way this is in feet? So we need to make sure that we check the unit and match it up. And because it's an area, all these units are squared. Okay, don't worry, I'll list all these exercises in the post. Now, in the very similar way that we did with the circumference, we can also work out areas if we have part of a circle. So it's the exact same process. You're just figuring out what fraction of the circle you have and multiplying that by the area of the whole circle. So if we had an angle here of 50 degrees, we really have 50 360ths of the circle, so that's why this equation is as it is. So we need to know that and how to use it. So let's look at this first example. So find the area of this sector. So A equals the angle, which we've got from over here, that's 60, over 360, multiplied by the area of the full circle, pi r squared. And it's important to keep this step in because you'll get marks for knowing your equation. So my next line, I just rewrite this and fill in the values that I know. So 60 over 360 multiplied by pi multiplied by 9.5 squared. And then that gets me 47.3. I would imagine we've rounded this off. And my units, because this is in meters, my area is going to be in meters squared. Okay. Right, so example 2 on this page is a shape which you can see is like a rectangle and half of a circle stuck together. Now we've already filled this in class and I've already gone through this, but obviously it wasn't originally split into the two shapes whenever we started, so we had to decide to do that. So if you're given a shape like this, then decide what way you can best split it up so that you can work out the area of the parts and then add them together. So I split this into a semicircle and a rectangle, and you can see I've labelled them 1 and 2. So area 1 is half of a circle, so that's why we've used this. We could have just gone in and used half here because we know it's a semicircle, we know it's half, but I just stuck to the system that we had already been doing. So 180 over 360 multiplied by pi r squared. Now be super careful here, because if we look back at our diagram, this length here is 16 centimeters, but that is the diameter. So if you see under here, I figured out the radius is going to be 16 divided by 2, so my radius is 8 centimeters, and that's why I've put my 8 in here. Anyway, that got me that area for that semicircle. Then this rectangle, nice and easy, length times breadth, 20 multiplied by 16, so we had 320 centimeters squared. Now, to get the total area for the shape, all we had to do was add those two shapes together. And that ended up getting us 421 centimeters squared. Oh, there's a lot of content in this year 9. I hope we're all doing alright. Now, the last section in this unit, which was what, unit 6? Is calculating volume of cuboids, first of all. Now it's relatively straightforward. The equation that we use is length times breadth times height, and you can see these labelled here. Now just be careful, breadth is sometimes called width. They both are just used to mean the same thing. So this is the equation that we need to know. There's lots of equations to know for this test. So find the volume of a cuboid with length 5, breadth 7 and height 12. All I've done is write out my equation, length times breadth times height, and then substitute it in my numbers. So length is 5, which is where that 5 has come from. Breadth is 7, that's that. Height is 12, and that's that. Multiply all those together, got me 420. Now the units of volume, because we're multiplying 3 centimeters together, we end up with centimeters cubed. So all volume units are cubed. And then example 2, very similar. Write out our equation, length times breadth times height. Length is 6.5, breadth 3.7, height 9.5. That got us this, 228.5 centimeters cubed. Now, we all hated doing this. Do you remember this? So, if you're given a shape like this, this is how we did it, okay? So this is like a sideways L shape the whole way through, okay? So the equation that we're best using to calculate this is cross-sectional area multiplied by length or height, doesn't matter. So what I did here was forgot at the start about the fact that it is a 3D shape, and I just worked out this area as if it was a 2D shape, and I just had to work out this area because we can all do that, no bother. Because we split this up, I split it into 2 rectangles this way, you can see how I've done it. And any missing dimensions we had to figure out as we went. So area 1 ended up being 15 multiplied by 6 to get us that 90 centimeters squared. If you're wondering where that 6 came from, it is just because this whole length here is 18 and from here to here is 12. So this has to be 6 because these two have to add to give us 18. And then area 2 is length times breadth. That's another rectangle. So 12 multiplied by 7. And we use the same technique to figure out the 7, because we know from here to here is 15. Here to here is 8. So this has to be 7, because these two have to add to give us the 15. Then we added these together to get the area of this side. All together is 174. Once we know that, then we can multiply that by 5 in this equation, cross-sectional area multiplied by length, and that gets us our volume. So we did find these questions tricky enough whenever we were doing them in class, so we need to make sure that we're spending some time on those in our revision. Now, year 9, this was a lot of information in one video, so what I'm going to say, and I'll say this in the post on Google Classroom, watch parts of the video at a time and then do the work that goes with the notes that I've just talked about. And we'll maybe spend a couple of lessons on this. I had originally planned to just do one, but in recording this, I've realised how much content it is. So we'll probably give 2 classes to this. Okay? Talk to you soon.